Acoustic impedance. To produce an ultrasound scan, we need reflections from several boundaries within the body at different depths. This requires some of the ultrasound to be reflected at a boundary and some to pass through that boundary. The property that allows us to calculate the proportion of the ultrasound that is reflected is called the acoustic impedance. Acoustic impedance is equal to the density of the material multiplied by the wave speed or the speed of sound within that material. In symbols we can say the acoustic impedance Z is equal to the density ρ multiplied by the wave speed c. Air has a density of around 1.3 kilograms per cubic meter, and the speed of sound in air is around 340 meters per second. So this gives an acoustic impedance for air of 1.3 times 340, or 440 kilogram meters to the minus 2 seconds to the minus 1. Here we have a boundary between two materials, the first with acoustic impedance Z1, the second with acoustic impedance Z2. If an ultrasound of intensity I0 is going from Z1 towards Z2, some will be transmitted, some will be reflected. If I say that the intensity of the reflected ultrasound is IR, and the intensity of the transmitted ultrasound IT, we find that the intensity of the reflected ultrasound to that entering the initial ultrasound is given by this expression. So if the ultrasound is going from air with an acoustic impedance of 440 to skin with an acoustic impedance of 1.6 times 10 to the 6, then the intensity reflected over the initial intensity is given by this term, which comes out at 0.999. This tells us that virtually all the ultrasound would be reflected by the skin, not allowing much of the ultrasound to actually enter the body. The gel, which is applied between the ultrasound transducer and the body, has a similar impedance to skin, and this allows most of the ultrasound to be transmitted into the body. This is known as impedance matching.